This is Len. Len is a biologist, and he's trying to figure out how many whales there are in the Baltic Sea. To do that, he's using a method called passive acoustic monitoring density estimation. Like the name implies, this method uses the sounds whales produce, counts them, and then transforms them into estimated density, which is essentially the average number of individuals in a population per unit of area. Len is trying to estimate how many whales there are in an area of 1 square kilometer. Thanks to previous research, he knows that when whales are foraging, they produce around 2 echolocation clicks per second, which is a type of sound whales can produce to communicate with each other and locate their prey. In the course of an hour, 3,600 seconds, he counted a total of 72,000 sounds. To estimate the number of animals, all Len has to do is divide the number of detected sounds by the recording length, and then further dividing that by the number of sounds produced per animal per unit of time, meaning there would be about 10 animals, right? Well, not so fast. There's something Len hasn't accounted for. See, whales aren't always producing sound, which means that sometimes they're simply silent. That's a very important factor to consider when calculating the CUe rate, which tells us how many sounds per unit of time the animal produces. So, when trying to understand what the CUe rate is, Len needs to consider those silent periods as well, and once he's done that, the CUe rate will be lower when averaged over a long period of time. Even though Len is quite an experienced researcher, this often confuses him, just as it does his colleagues, because this means that the CUe rate for passive acoustic monitoring density estimation is not necessarily related to any rate with an ecological meaning. Here's an example of what this can look like. Represented in this graph, we have what we call the depth profile of a beaked whale. On the y-axis, we have the depth at which the whale is, and on the x-axis, we have the time since the start of the recording. The blue lines highlight when a deep foraging dive is initiated, the colored red dots represent the times when the whale is producing sound, and the colored green dots represent the times when the whale is silent. Notice how the whale tends to click at depth? That's because they're echolocating to find their prey. So, after exploring these patterns for his species of interest, Len realizes that the animals spend about 50% of their time silent, and this changes things quite a bit, because now, to estimate the CUe rate, Len has to account for both silent and vocal periods. To do so, he multiplies the number of sounds per second that the whale makes by the proportion of time it spends making sounds, and adds it to the number of sounds it makes when it's not clicking, which is always 0, multiplied by the proportion of time it spends silent. So in this case, that means 2 times 0.5 plus 0 times 0.5, meaning a CUe rate of 1 and not 2 clicks per second as previously considered. Therefore, the density of animals is 20 whales per square kilometer and not 10. So it's safe to say that it's important when whales are making sounds, but it's just as important to know when they're silent. We are most interested in the long-time average of sound production and not just sounds while in a vocal state. So we need to be careful when thinking about CUe rates for acoustic density estimation. They might not correspond to a biologically meaningful rate, but it's the value we need to estimate abundance or density from CUe counting,